Welcome to Unit 3, Lesson 2, Trigonometry Functions in the Unit Circle. Oh, love this stuff. Hopefully you will too at one point, but most of you are like, no way. Anyways, SOHCAHTOA, sine, cosine, tangent, all this good stuff. And knowing two very important reference triangles, these things are key to finding out values of angles, okay? In order to find exact values of sine, cosine, and tangent, we need to know a couple of things. And this is how I do it. You may do it differently, but this is just it's just the way I do it, okay? For me, one, I need to know which angle I'm referencing. So in a triangle, I need to know, okay, the 30 degree. I need to know where the 30-degree angle is. Because after I figure out what angle they're asking me to find the exact value of either sine, cosine, or tangent of, I'm going to label my sides. Label my sides. And they will either be opposites, adjacent, which means next to, and hypotenuse. All right, you want to label your sides so you know what angle you're evaluating. Okay, label the sides based on that angle, either opposite, adjacent, or hypotenuse. And then three, and this was on the cover page, SOHCAHTOA. Now, many people, and this is weird, when I used to go over this in 9th grade, back in the day, some kids are like, I never knew what SOHCAHTOA actually meant until you explained it. I'm like, why would we even say something like SOHCAHTOA and not have a meaning behind it? But sine is opposite over hypotenuse. Okay, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So you can see kind of SOH, SOH, CAH, CAH, TOA, TOA. It kind of just, it tells you the order they go in and everything. Okay, SOHCAHTOA. And last but not least, as we get a little bit further into this, after you find your sine, cosine, or tangent of whatever trig function that you're evaluating or finding the exact value of, you need to remember, you need to know, is it positive or negative? Okay, because we can have positive and negative sine and cosine values depending on where your angle falls in our unit circle. Don't worry, these words might seem foreign to you, but eventually we're going to get there. And number 4 is a just a little something at the end that you need to do that students always like. Sometimes they forget to do it. Okay, you just need to make sure you know whether it's a positive or negative value. All right, so things to think about. All students take calculus, okay? You can come up with any word that begins with C for that 4th word, and all students take calculus. And trust me, my students and I come up with some real whippersnappers, but however you can remember it is okay by me. Now, let's not forget from Unit 3, Lesson 1, our special triangles, our 30, 60, 90 triangle, and our 45, 45, 90 triangle, because these things come into play eventually. You can't forget those values, okay? So what do we have here? We have all students take calculus, all right? And notice I highlighted the first letter in each one of those words, okay? So here's quadrant 1. Here's quadrant 2. Okay, here's quadrant 3. And last but not least, quadrant 4. All right. If I go in that order, all students take calculus. Now, what do those letters, the A, S, T, and C, represent to me? That tells me which trig functions are positive in what quadrants. So the A stands for all. All trig functions, sine, cosine, and tangent, are positive in quadrant 1. Okay? In quadrant 2, only sine is positive. That means cosine and tangent are both negative in quadrant 2. Okay? And if we go around, I think you can kind of tell what's going to happen. Quadrant 3, only tangent is positive here. That means sine and cosine are both negative in quadrant 3. And in quadrant 4, cosine is positive. That means sine and tangent are both negative. So if I have an angle, for example, that happens to be in quadrant 4, I got some angle in quadrant 4. If I want the cosine of that angle, I should end up with a positive value because cosine is always positive there. But if someone wants me to figure out the tangent of an angle in quadrant 4, whatever I get, my tangent should be negative, so my answer should be negative. Okay, if I'm taking sine or tangent of any angle that the terminal side, okay, that ends in quadrant 4. All students take calculus, ASTC. Okay? So let's try to find exact values of each of the following angles they give us here. And what do we have? A total of 6 problems? Yes, we do. Let's do this. So sine of 60. The first thing I'm going to do is draw an axis and draw a 60-degree angle. Starts at 0 degrees. Here's 90. 60 is probably up something like this. This is 60 degrees. Okay? Now, I'm going to draw a triangle. Just draw a straight line down. If this is 90 degrees, don't I now have a 30, 60, 90 triangle? I do, and that's why it's important to remember the sides. It is 1, radical 3, and 2. So, the sine of 60. Sine equals opposite over hypotenuse. So, this is opposite of 60. This is adjacent of 60. And 2 is my hypotenuse. So in order to do that, it is opposite, radical 3, over my hypotenuse, which is 2. And that's the first quadrant. Sine is positive in the first quadrant. So my answer is a positive radical 3 over 2. Let me state that one more time. Okay? I'll do purple. All students take calculus. How do I know this answer is positive? Because all my trig functions are positive in quadrant 1. It doesn't matter what trig function I was doing, it should always be positive. Okay? Let's go on to choice 2, or problem 2. Tan, again. I'm going to draw this set of axes here. Okay? 210 degrees. Okay, 0, 90, 180, 270. So 210 falls right in between. I start at 0. It's in between 180 and 270, probably a little bit closer to 180. From here to here, that's 210 degrees. My reference angle, remember, it's the acute angle, and it's always to the x-axis, is right here. That's 30 degrees. So if I draw a straight line down, I again have a 30, 60, 90 triangle. Okay? And I know my sides. 1, radical 3, and 2. All right? So now tangent. Tangent tells me opposite over adjacent. So let's label my sides here. Opposite of 30 is the 1. Adjacent to 30, or next to 30, is the radical 3. And my hypotenuse is 2. So it is opposite, which is 1, over radical 3, which is adjacent. Now, is it positive or negative? All students take. Tangent is positive in quadrant 3. So my answer should be positive. That's a good answer. Okay, if they ask you to simplify, I need to multiply the top and bottom by radical 3. If they ask me to simplify, I would need to simplify it like that. Okay? Good, 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 very good, very good. Let's go to example 3. All right, let's give ourselves a little bit more room here. Example 3, cosine. Ooh, I've got to draw a negative angle, which means I need to go clockwise. Here's 0, here's negative 90. Okay, negative 45 is exactly in between those two. So, you do, This will be negative 45 degrees, okay? Which means my reference angle is 45. I'm moving 45 degrees in a clockwise motion starting from 0 degrees. Let's draw our triangle. We have 45, 45, 90. That's 1, 1, radical 2. That's because I know my sides. If you know the sides of those two triangles, these will be so easy to do, okay? And I know cosine is adjacent over hypotenuse, all right? Well, let's label our triangle. Opposite of my reference angle is this one. This one is adjacent. This radical 2, is hypotenuse. So it is adjacent, which is 1 over radical 2. I need to make sure that I know if that's positive or negative. So, yep, that's the wrong end of the marker. All students take calculus. Cosine is positive in quadrant 4. This is cosine. So this answer needs to be positive. What I might do is simplify that. Okay, so I maybe multiply the top and bottom by radical 2, and that is the simplified form, okay? But if they don't ask you to simplify it, 1 over radical 2 is perfectly acceptable. If you want to try 4, 5, and 6 on your own, go ahead and do that, and then I'm going to do them right now. Let's see. All right, and let's start with the cosine of 120 degrees. 120 degrees, I know that should be in quadrant 2. So if I draw, here's 0 degrees, 90 degrees, 180. Okay, 120 degrees. Here's 0. It's probably closer to 90. From here to here, that's 120. Okay, which means my reference angle is 60. So I'm going to draw a triangle straight down like this. Okay, and I know if my reference angle is 60, I have a 30, 60, 90. And I should know the sides of the triangle. 1, radical 3, and 2. All right? And I'm going to label that. Opposite is my radical 3. Adjacent is my 1. Hypotenuse is my 2. Cosine is adjacent over hypotenuse. Okay? So it is adjacent, which is 1, over hypotenuse, which is 2. The last thing I need to do is check to see if it's positive or negative. Oh, students, take calculus. In quadrant 2, only sine is positive. Cosine and tangent are both negative. They want the cosine. So it has to be negative. So I need to put a negative here. The amount of students that leave that 1/2 is crazy, okay? You need to make that negative. Now, I want to show you another way students can remember this. And you can choose whatever way you want, the all students take calculus or the way I'm about to show you right now. I'm going to erase some of this so, we have a little bit of sanity in our mind. We just don't have graphs and trig functions thrown all over. I'm going to redraw this axis and triangle for problem 4. This isn't for 1 anymore. This is still problem 4. I'm redrawing it. Okay, 120 degrees was here. It was here. This is 120. We said this was 60. If we drew a triangle, I know it should be 30, 60, 90. Okay, now here's the next. If you don't want to remember, all students take calculus. How else can I remember? Our hypotenuse was 2, radical 3, and 1. Now, anything in quadrant 2, if I were to plot a point anywhere in quadrant 2, it would have to have a negative x value and a positive y value. What do I mean? I would have to go negative on the x and positive on the y, correct? So this value would be negative going to the left, and this value would be positive going up. So now my adjacent side is -1, right? And my hypotenuse is 2. So if I still did cosine, it's adjacent over hypotenuse. It's -1 over 2, and there you go. You have your negative there. you can think of it in terms of x's and y's, okay? Any coordinate, okay? Any coordinate that I plot in quadrant 2, any coordinate that I plot there, okay? Again, I'm going to do another axis. Any coordinate in here would have to have a negative x value and a positive y value, wouldn't it? That's why this is negative and this is positive. That's why sine is positive in there, okay? Because sine is opposite over hypotenuse, and opposite is radical 3. So you can look at it that way in terms of like logic as far as x and y coordinates. Or you can remember that all students take calculus. Either way is fine by me. Either way, as long as it's mathematically relevant. Okay? So now, let's move on to problem 5. Negative 135. Set of axes. I'm moving negative this time, so it's negative 90, negative 180, and guess what? Negative 135 is exactly in between those two. That's negative 135. My reference angle has to be to the x-axis. That's 45 degrees. So I am just going to draw a 45, 90. That is 1, 1, radical 2. Okay. If on the sine, that's opposite over hypotenuse, which is 1 over radical 2. Because if this is my reference angle, this is opposite, this is hypotenuse. Okay. Last thing I need to do with sine, is it positive or negative? All students take calculus. Tangent is the only positive there. Sine is negative in quadrant 3. So that should be negative. If they ask me to simplify it, there you go. Bam. We can start doing these quicker and quicker and quicker the more comfortable we get with them. All right? Tangent of 315 degrees. Let me clear some room here. Tangent of 315 degrees. I am, oh, that's negative 315. Mercy. So 0, negative 90, negative 180, negative 270, and back to negative 360. Okay? Negative 315 degrees, if I start here, would go all the way around to quadrant 1. That is negative 315 degrees, which means my reference angle is 45. So if I draw a triangle, 90 degrees, that's 45, 45, 90. That is 1, 1, radical 2. This is opposite. This is adjacent. This is hypotenuse. Tangent is opposite over adjacent. It is 1 over 1, which equals 1. Ah, students take calculus. All trig functions are positive here. So that's a positive 1. All right? Not so bad. You just need to do them to get comfortable with them, all right? You just need to get used to them. And they're actually not that bad at all. Let's take a look at some additional examples here. Angle theta. Remember, that's just a variable that represents an angle. It's fine. It's just like x or y or f or r, t, whatever. It's a variable. It's an angle in standard position. And B, that's point B, negative 3, 4, is a point on the terminal side of the angle. Find the value of sine. This looks all sort of foreign, but you know what? Until we draw a picture, it really, we really can't fully comprehend it sometimes unless we physically see it drawn out from the words to a picture. Some people need pictures. It's better. It's easier for them to learn. Okay? So I'm going to draw an axis. Okay? And I'm going to plot the point negative 3, 4. Here's negative 3. Up here is 4. So if I plot this point, it's right there. They're saying that point B is actually a point on the terminal side of angle theta. So if I start here at 0 degrees, my terminal side goes right through there. And this is angle theta. Okay? Now, they want to know the sine of theta. I know that's opposite over hypotenuse, all right? But what can I do? Well, I'm still going to draw a triangle, and I still have a right angle. I have a 90-degree triangle. My problem is I don't have an angle. I don't know what the reference angle would be. Is that a 45, 45, 90? Is it a 30, 60, 90? What is it? Well, my friend, okay, I went 3 spaces to the left, didn't I, on the x-axis, and I went 4 spaces up on the y. I now have 2 out of 3 sides of my right triangle. Oh, Pythagorean theorem, how I love thee. You never seem to go away as much as I want you to. You're just always hanging around. Okay, so let's say this is your hypotenuse, C. A squared plus B squared equals C squared. This is 9 plus 16. That's 25 equals C squared. Therefore, my hypotenuse C is 5. And I just use the Pythagorean theorem to find that third angle. So what's the important part there? This is my reference angle. Okay, right there, I'll do this. Yeah, this is my reference angle. I don't know what the value of it is, but I know this is opposite of it. I know this is adjacent of my reference angle. And of course, this is my hypotenuse. So, if sine is opposite over adjacent, that is 4, excuse me. If sine is opposite over hypotenuse, that is 4 over 5. The last thing I need to do, and this is what I say everybody always forgets, all students take calculus. They want sine, guess what? Sine is positive in quadrant 2. So I will leave this positive 4/5. So if we have the coordinate, okay, if we have the coordinate, we can have the 2 sides of our triangle, and the coordinate gives us the legs, actually, of the triangle. Okay? So make a little note here. My coordinate, in this situation, my coordinates gives me legs so I can walk. Okay, my coordinate gives me the legs, and then I just use the Pythagorean theorem to find the hypotenuse. Now, in a little bit, I forget what lesson coming up, the coordinate actually gives us something else when we get into the unit circle, but, you know, all these numbers, they just relate to each other, okay? So not bad. Number 2, same deal. If you want to try this, go nuts. Angle theta is an angle in standard position, and B is a point that has the coordinates -3, radical 1, and that point is on the terminal side of the angle. They want us to find not just the sine, the cosine, or the tangent. They want us to find all 3, the sine, the cosine, and the tangent of this angle. First thing I'm going to do is draw a picture, make it easy on myself. Okay, I know this is going to be in quadrant 2 because my x is negative. I got to go negative radical 3 up to 1. All right, I'm going to put this point right here. That's point B. Okay, I'm going to draw my angle. It starts here in standard position. Terminal side, or the end side, goes through here. This is theta. All right, I'm still going to draw my triangle. And it's a 90-degree triangle. I know this distance is radical 3. It just went negative. This distance is the y. It went up 1. Now, children, I could use the Pythagorean theorem here. I can. But those 2 numbers should be familiar to me. If I have, okay, radical 3, 1, this is 2. That's a 30, 60, 90 triangle right there. I could use the Pythagorean theorem. I could use a squared plus b squared is c squared, and my hypotenuse would end up being 2. Okay? But I know this is a 30, 60, 90 triangle right there. Okay? So I know this has to be 2. All right? This is your reference angle. You can say that's 30 if you want. You don't need to in this position. So what do we have here? We have, this is opposite of our reference angle, adjacent to our reference angle, and hypotenuse. Now keep in mind, all students take calculus. Sine is going to be the only positive. So when I figure out sine, which is opposite over a hypotenuse. Okay, that's going to be the only one that's positive. Cosine, which is adjacent over hypotenuse, is going to be negative. Tangent, which is opposite over adjacent, that's also going to be negative. All right? Sine is opposite over hypotenuse. Okay, it's 1 over 2. It's a positive 1/2. Cosine is adjacent over hypotenuse, so it's radical 3 over 2. And guess what? That should be negative, right? Cosine is negative in quadrant 2. And tangent is opposite, which is 1 over radical 3. And that should be negative. And if it's simplified, negative radical 3 over 3. There you go. Those are all 3 trig functions, sine, cosine, and tangent, of theta. If it has a point that is on its terminal side of negative radical 3, 1. Okay? This might seem foreign to you because there are no numbers. I mean, there's zeros. But this is really, really easy, especially if you know all students take calculus. So that might be one way to figure out all students take calculus, to use that to find out if you have a positive or negative answer instead of using the coordinates. For example, in which quadrant, okay, does the terminal side of the angle lie if sine is positive? That's what this means. If sine is greater than 0, that means sine is positive. And cosine is less than 0, that means cosine should be negative. So first, let's worry about this right here. Let's figure out where sine is positive, okay? Sine is positive. First of all of them are positive here. So you have sine, cosine, tangent. They're all positive. Students take calculus. Okay, sine is positive here. That means cosine and tangent are negative. Okay, I could do the rest, but first, let's figure out where sine is positive. Sine is positive in quadrant 1 and in quadrant 2. Okay, so not only does sine have to be positive, cosine should be negative. So out of all this area up here where sine is positive, where is cosine negative? And cosine is negative right here. This has both a positive sign and a negative cosine. Quadrant 2. So I'm going to say quadrant 2. That's my answer. They asked me, what quadrant? There's my answer, quadrant 2. Sine is positive? Yep. Cosine is negative? Yep. Those ones are easy. I love those. Given that sine of theta is 3 over 5, and that theta is in between 90 and 180 degrees, that means it's in quadrant 2, people. We will visually draw that so that you understand that in a second. Find the cosine of theta. All right, well, let's draw it. There you go. Here's 90. Here's 180. Okay, here's 0. I know some angle. It's right here. I'll just draw that in the middle. Okay, that's theta. All right, and again, I'm going to have a triangle. And this is my reference angle. This is important because if sine is 3 over 5, that's opposite over hypotenuse, isn't it? So opposite is 3, and hypotenuse is 5. Right? They want cosine. Cosine is adjacent over hypotenuse. Okay? My hypotenuse is 5, but I don't know what my adjacent is. Right? What do you think I'm going to do if I know 2 sides of a right triangle and I need the 3rd side? You guessed it. Back to our Pythagorean theorem. Okay, one side is 3 squared, plus I'm trying to figure out the other side, equals 5 squared, my hypotenuse. So 9 plus something is 25. If I subtract 9 from both sides, that's b squared, I should get 16. Okay, so b squared should be 16. And if I take the square root of that, my b value should be 4. This should be my adjacent value right here. And if that's adjacent, that goes right here. Now, you cannot forget, is that a positive or a negative cosine? Oh, well, all students take Calculus. Sine is positive. Cosine and tangent are negative. Cosine should be negative. All right? Booyah. So lastly, we come to this question here. And maybe it's a good question. Maybe you've been thinking about it the whole time. I don't know. How do we find the exact value of sine, cosine, and tangent of quadrantal, which are 90, 180, 270, 360 angles? So angles that fall right on our axis. How do we find those points, okay? Well, first of all, we need to understand this circle is called the unit circle. It's to the left, and angle theta is the unit circle. Wow, blank. That's weird. Anyways, the unit circle has a center. Let's just forget about this. Okay, the unit circle has a center at 0, 0 and a radius of 1. So this is 0, 0, and this goes out 1. What is the coordinate here? That's 1 on the x, 0 on the y. And that becomes very important. So this is 0 degrees, 90 degrees, 180 degrees, 270, and back to 360. Now, I said that your x and y coordinate earlier in this lesson means something different, okay, on the unit circle, and this is where we're getting at, okay? So if I do this point, that's 0 on the x, and that's 1, positive 1 on the y. Okay, so we're going to go ahead and put these coordinates right here. That's negative 1 on the x, 0 on the y, and this is 0 on the x, negative 1 on the y. How do I get that? Because the radius is 1. I'm going 1 in all these directions. That's how I know it's 1, 0, 0, 1, negative, and so forth. Okay? Cosine. Cosine is always equal to the x coordinate. Okay? So as I go around this, if I want to know what the cosine of 0 degrees is, well, that's the x value at 0 degrees. What's the cosine of 90? It's the x value at 90. What's the cosine of 180? The x value. The cosine of 270? It's the x value. So I'm going to go around here, and I'm going to say, okay, well, my cosine of 0 degrees or 360 is 1. The cosine of 90 is 0, okay? The cosine of 180 and the cosine of 270. So if the cosine is the x value, what do you think the sine is? The sine is the y value at all these points. The sine would be the y value at all these points. So the sine is the y coordinate at all of these points, okay? And last but not least, well, let's write this here. Here's the sine. Here's the sine of 90. Okay, it's literally right in front of your face, sine of 180. And the sine of 270. Well, what about tangent? Tangent of the angle is always, well, first of all, tangent is sine over cosine. And if we do that in forms of our x and y coordinate, isn't sine our y coordinate? And cosine is our x coordinate? All right? So tangent would be, I would just divide them. So really, all we need is the coordinate there. And since the unit circle has a radius of 1, it's always 0 with a positive or negative 1. You're either going to have an x or y that's 0. And the other coordinate, the other whatever x or y is not 0, will either be positive or negative 1. And that's just literally graphing it. Okay? So if I go down here, okay, what's the sine of 0 degrees? The sine of 0 degrees is 0. Okay? What's the cosine of 0 degrees? Okay, what's the cosine of 0 degrees? It's 1. And isn't the tangent, okay, this is the sine is the y, the cosine is the x, tangent is y over x. So let's just create a fraction here. That's 0. Okay, sine of 90 is 1. Cosine of 90 is 0. If I divide them, I get undefined. I can't have 0 on the bottom of a fraction. Okay, at 180, 0, negative 1, that's 0. Okay, at 270, we're back to 270 is right in front of my face right here. Okay, cosine is 0, and this is -1. If I divide them, I get undefined. There you go. Bam. So if I kind of went through that kind of quickly because I was just referencing the points, but if you want to associate the points with this table, go right ahead. And that's a good lesson. I'll see you for Unit 3, Lesson 3.